All right, class, here is section 2.2. We will be looking at linear equations. We already know what linear means. The variables are to the power of 1. Equations is got an equal sign, and then we'll look at inequalities again. But what's changing now is that we will have two variables. So for example, right here are my two variables in my linear equation in two variables, okay? The other thing that changes is that we won't say solving linear equations anymore. We'll be saying graphing, and I'll explain in a minute why that is so. So here it is. A linear equation in two variables has the standard, or sometimes we also call general, form ax plus by equals to c, where a, b, and c are given numbers. So in other words, x and y are the variables, or the things that keep changing. So here, for example, some number times x plus some number times y equals to some other number. We've actually been graphing these equations since R3, the review section 3, and then even some more. We talked about functions in chapter 1. So we've actually been looking at a lot more complicated equations in two variables. But remember, I said we're starting back from the beginning and looking at specific ones in very much detail. So we will be looking at the linear equations in two variables in very much detail. So when we solve such equations, we're going to get not just an answer for x, but also an answer for y. So our answers are ordered pairs. And if we try and come up with some answers for this, we, by the way, have already done some in the previous chapters. Let's say I'm substituting x with 0. Then how much is the corresponding y going to equal to? Again, we've just practiced on solving equations in one variable, really easy. Let's say I pick y to equal to 0, then how much is the corresponding x to it? Well, if I pick y to be 0, that simply means I have to substitute 0 for y. And then again, easily, x comes up to equal to 3. So there are two solutions that we came up with. And it turns out there are a whole lot more. So let's say I make, not 3 because we already have that, sorry. Let's say x is negative 3. Okay, then how much would I get for y? And I'm going to delete this piece here. I'm going to substitute x with a negative 3. So that's negative 6. Add the 6 over, and I'll get a 12. And so therefore divide by 3, so x is 4. Okay. And you can go on, and I don't want to waste too much time because we in fact don't need more solutions. Okay. So any such equation, again, two variables, really, any equation in two variables, doesn't have to be linear, has infinitely many solutions of the form x comma y, right? We need an answer for x and an answer for y. We call these ordered pairs, right? So because we have infinitely many solutions, we cannot list all of these solutions. So to solve an equation means tell me what the answers are. Well, there's going to be way too many answers here for me to list. In fact, infinitely many of them. I'll never be done with this problem, right? So instead of solving such equations, we graph the solution set. So let's graph the solution set for the problem above. Okay. And we graph the solution set on our rectangular coordinate system also called Cartesian coordinate system, also called the XY plane. So I'm going to take some of these points I found here. X is 0, y is 2, x is 3, and y is 0. X is negative 3, and y is 4. And you can find as many more as you wish. However, it turns out that all these points are going to be in a line. Therefore, linear equation. We discussed this already. So all these points are going to fall on a line. Infinitely many points on this line. Infinitely many solutions to this equation. Any point on this line is a solution to the equation and backwards. Okay. So as you see, all these points fit on a line. Okay. And we, in fact, only need 2 points to draw a line. So we will only need to find 2 solutions. So we will only need to find 2 solutions. Now, the best ones to find are the what we call x and y intercepts. So to find the intercepts, all you have to do is make x equal to 0, find the y, make y equal to 0, find the x. So that's exactly what we're going to practice in the next problems. Here it is. Graph the linear equations in 2 variables. So I said the best thing for me to do would be to find the intercepts. So pick a value for x, find the y to it. Okay, so pick zeros. That's really easy because if I plug in zeros, that makes the 3 times 0 go away, right? So I divide by -5 and I'm going to get -3 for y. So one possible solution is x is 0, y is -3. Then I need a second point, so make y be 0. If you plug in 0 for y, you don't even really have to write all of this because you know that if you plug in 0 for y, the y term goes away, right? So I'm left with just 3x equals to 15, and dividing by 3, that makes x a 5. So here is the line connecting these 2 points. By the way, these are called intercepts because look, these are the 2 points through which the line crosses through the 2 axes. They are the intercepts, where the line intercepts, or in other words, crosses the axes. Okay. So let's try and do this the same. Pretty straightforward. Make x 0, find y. Make y 0, find x. And again, remember, if x is 0, what happens to the x term right here? It's gone, yes? So to solve for y, all I have to do is take 16 and divide it by 7. This might be a little hard to graph, but if I take my calculator and take 16 and divide it by 7, I know that's about 2.28, so fine, about 2.3. I know where about 2.3 would be. I need a second point, so now I'm going to make y equal to 0. If I make y equal to 0, then this piece is gone out of the equation. So to get to x, I just divide by -2, so I'm going to get -8. So that's how easy it is to find intercepts. One at a time, the x term goes away, the y term goes away. So let's plot them. -8 would be just a little bit outside. The 0y, I said 2.3-ish is just about here. Okay, so if you get fractions, it's kind of hard to know where 16/7 is. But as soon as you turn into a decimal, you can find it on the number line easily. And here's the line. I found my two intercepts. So let's practice a couple more. Again, you're welcome to stop the video and try yourselves. This one's really easy, the one I'm making you try yourself. If x is 0, 0 plus 5 is 5. And if y is 0, then x is 5. And there it is. The next problem is a bit tricky for this reason. Let's say I make x to be 0. Then what is y going to equal to? So 3 times 0 is 0 for x. That's gone. I'm left with 5y equals to 0. If I divide both sides by 5, check your calculator, but 0 divided by 5 is 0. If I go backwards and make y to be 0, guess what? The same thing happens to x. There's just one way only what these numbers get paired with. This is a 1-to-1 function, if you remember those. Okay, so you really haven't found any point that's different. It's just 0, 0. So that's because the line we're about to draw intercepts or crosses through both axes at the same time through the origin. So it's not two separate points, two separate intercepts, just one intercept. It crosses through both axes at the same time in the origin. Now, we have infinitely many points. Just because we pick zeros to make it easy for us to find the 2 points doesn't mean we can't pick anything else. So you can pick any numbers, right? 0, 0 led us to 1 point only. There are infinitely many points on these lines. Just pick any other number than 0. So if we pick x to be 1, subtract the 3 over, we just practiced. These problems are not that long. So y is going to equal to -3/5. That's a different point. X is 1. Y is -0.6, by the way. Okay, that's the point. So again, 0, 0, 0, 0, that's the same point. That doesn't help us any further. But remember, you can pick whatever numbers we want, right? We pick different values other than 0 here. If we could just get away with just picking 0 for x and find y and 0 for y and find x and we got 2 different points, then great. We got our 2 different solutions, yes? But sometimes it so happens the line crosses through both axes in the origin. Okay. Here are some special lines. These special lines actually do not have both variables in them. So let's say I'm looking at the equation x equals to 4. That simply means 1x plus 0y equals to 4. So remember, we said an equation in 2 variables has the general solution, some number times x plus some number times y equals to some other number. Note where these a, b, and c values are real numbers. Well, they could very well be zeros, right? Look, this last problem, the c was 0, yes? But the coefficients of x or y could happen to be 0, okay? So if the coefficient of y is 0, all I'm left with is x equals to 4. So this line is special line, and it's going to look like x is 4, and all the x's on this line are always 4, nothing other than 4. Y could be anything. It doesn't matter what you're going to plug in here for y. It makes no difference because it gets multiplied by 0. So we will get a vertical line anytime we're missing the y out of the equation. Now, you know you're dealing with an equation in two variables because the instructions will say graph. So when I have to graph x equals to -2, I'm going on the x-axis at -2, and I draw a visible line. The same way, horizontal lines will have equations that say y equals to some number. And by the way, those are the constant functions we discussed in 1.3. Because remember, f of x equals to 2, we said is y equals to 2, which is a horizontal line crossing the y-axis at 2. So, again, the fact that we have just the y, it means that the coefficient of x is 0. So it makes no difference. X could be anything, but y always comes up to equal to 2. So let's say I want you to graph y equals to -3. Great. Go to the y-axis at -3. And it's not just a point, it's a whole line of answers that is going to be horizontal. Okay. So we're going to practice on graphing linear equations in two variables even more, because to graph a linear inequality, the first step we're going to do, same as what we did in the last section, we're going to do the same exact steps, but as we would do for the equation. So in other words, when I'm trying to graph an inequality, here are the steps. And I did write them down below. I copied this actually out of your textbook. But I will summarize right here. So the first thing, draw the line. In other words, make this an equation. Make it equal to 3. So that's what we just practiced. If x is 0, y is 3. If y is 0, x is 3. Okay. So this boundary line is the solution to the equation. So it's the same as what we did earlier. Whoops. It's the same as what we did earlier with graphing the solution to the equation on the number line. Well, it's not the number line anymore, as we're dealing with two variables. So we need that boundary, in this case line, before point, right? In 2.1. And then our answer is going to be either all the way here to the left or all the way to the right. Because we are actually dealing with two variables, some coefficients might be negative, and then we might think of flipping the sign. What we do every single time is we pick a test point. So we test, and again, the instructions are very detailed down below. We will test the point not on the line. Usually, again, because we want to keep things simple, test the origin if it's not on the line. And where I test it is in the inequality. So is 0 plus 0 greater than 3? No. 0 is not more than 3. So 0, 0 is not in the answer. Therefore, the answer is on the other side of 0, 0. Okay. And it would kind of make sense the way it was pointing more than 3, you're going to go above. Now, the other detail here is you saw that this boundary line was, I drew it dotted. It's the same thing as, let's say, me solving an equation, an inequality in one variable, and I end up with x is greater than 3. What do? On the number line, we put this boundary of 3. We go above, so to the right of 3, but 3 is not included, so we put our open circle. The same idea here. The boundary line is not included, so I can't put an open circle because it's not just a point, it's a whole line, so we draw it dotted. Okay. Now, if our line here, I'll take this on the side, take the equation, make it an equal sign, and draw this boundary line. So same thing, make x 0, find y, make y 0, find x. I'm gonna let you do that. If you make x 0, this term is gone, and I take 9 and divide it by 6, so I get 1.5. If y is 0, then this term is gone. So I take 9 and divide by -3, and I'll get -3. So here are my two intercepts. X is -3, y is 0, and x is 0, y is 1.5. Now, as you see, this inequality says or equal. Therefore, the boundary line is included. Therefore, I'm going to draw it solid. I still need to test what happens. So, is -3 times 0 plus 6 times 0, which is, by the way, both 0, greater than or equal to 9. So 0 is not more than 9. Therefore, 0 is not in the answer. Therefore, I have to shade on the other side of where 0, 0 was. So here are just a few more, and I realized that I made pretty much all greater than, so just to make sure we get mix up the problems, I'm going to put a less than. So one more time, make it an equal sign to draw your boundary line. So best way to find the 2 points in this case is to find the intercepts. So if you make x 0 and you take 9 and divide it by -1.5, you should get -6, but I will test that. Yep. And now if you make y 0, 9 divided by 6 is the 1.5 we had earlier. So here it is, -6 for y, 1.5 for x. This inequality said or equal, so I draw the boundary line solid. And then I have to see which side of it I need to shade. So for this, I pick any point that I know is not on the line. And again, we pick 0, 0 for two reasons. We already know where 0, 0 is. The origin is easily to identify. Second of all, we really don't have that much to compute when we plug in 0 for x and 0 for y. So that's a 0, and is 0 less than 9? Yes, it is. Therefore, the side with 0, 0 is in the answer. Okay, here it is, one more. This one, I'm giving you a vertical line. X equals to 4 is a vertical line. We just talked about it. Less than 4, this one you don't really need a test point because where are all the x's less than 4? Well, to the left. But even if you plug in 0, 0, you see that yes, 0 is less than 4. Therefore, the side where 0, 0 was, where the origin was, is our solution. And again, you may want to pause and try the last problem, and then come back and see what happens. Make x 0, y is 2. Make y 0, x is 2.5. X is 0, y is 2. X is 2.5, y is 0. This line will be dotted because it doesn't say or equal. And now we want to test again the origin. So it's 4 times 0, which is 0, plus 5 times 0, which is 0, more than 10. No, 0 is not more than 10. Therefore, the side that does not have 0 is the answer, because 0 is not, 0, 0 is not in the answer. Okay, there it is.